Okay, sorry about that. All right, we got disconnected. You're probably going to see two recordings up today. So, all right, let me get back. Okay, you guys still here? No, yeah, there you are. All right, can everybody hear me? Okay, I did a hot. Can you hear me okay? I sent a text. Okay, thank you. All right, so let's go back now. We had just finished up the, I'm running off a hotspot off my phone, so I think the Cox went down here in the neighborhood. All right, so we just finished the left side, soluble side. Now, on the right side is the insoluble side. All right, so with respect to the insoluble side, we got number one, the carbonate. All carbonates, all the anions that are bonded to whatever metals out there are insoluble, except when they are attached to the big four. Okay, so there's only 4 species of carbonates that are soluble. All 10,000 other examples are insoluble. Okay, the same is true for chromate. Chromate, everything with chromate is insoluble except the big four. So you got lithium chromate, sodium chromate, potassium chromate, ammonium chromate, and the same is true with carbonate. Again, with the phosphate, same scenario. All the phosphates are insoluble except lithium, sodium, potassium, and ammonium, right? Now, all sulfides are also insoluble except the 4 plus calcium, strontium, and barium. And so, all right, thank you, Debbie. I just got that. So there are 4, 5, 6, 7 examples of sulfides that are soluble, and every other example is insoluble. And then here we go with the hydroxide, the bases. And so all the hydroxides are insoluble, making them weak bases, except the big 4, and also calcium, barium, and strontium. So that means that there are 4, 5, 6, 7 strong, they're soluble, making them strong bases. Only 7 strong bases. All the other metal hydroxide combinations are weak bases. Okay. And that's how we utilize the table to help us out. Okay. So if we look at some examples, the questions, are they soluble or insoluble? All right. So to answer that, we just basically first find out what we're working with. We got the sulfide, sodium sulfide, which normally are insoluble. Okay. But it is attached to sodium. In fact, we can find over here potassium also. So sodium, potassium, 100% of the time, always soluble. And so the first one, it would be designated as AQ because it is soluble. Okay. Second one is the hydroxides. Well, there's only, the big 4, and then the other 3 that are soluble. Okay. And that means that all the other hydroxides are insoluble. So we designate aluminum hydroxide as S, okay? Same is true for silver bromide. Normally the bromides are all soluble unless they're attached to the heavy metals. I call them the heavy metals because they're big metals, the silver. So silver bromide would be insoluble, okay? And then good old carbonate. Carbonate number 1, which is normally insoluble unless it's the big 4. Well, calcium is not part of the big 4. So calcium carbonate would be insoluble. It's also known as, a lot of the cakey material around faucets and so forth. A lot of it's calcium carbonate, especially if you got a lot of heavy water. And then the last one, you got potassium. You don't need to go any further. It is soluble, okay? And clear this up. So with that being defined, you can, if necessary, draw diagrams of these beaker diagrams where you got all the sodium in solution and the sulfide, okay? The aluminum hydroxide, I would have the bulk of it down here and then one set of aluminum hydroxides in solution. The same is true for silver bromide because this is insoluble, but I have one set of silver bromide in solution. Calcium carbonate, similar scenario. Down here in the bottom would be a calcium carbonate. And then I'll have one set of ions in solution. Do not forget their respective charges. And then the potassium, obviously, I can say 3 potassiums there and 3 nitrates. I don't have to draw each one individual, 3 of them individually. I can do that. That's fine. I'll accept that. Okay. All right. So that is the using the periodic table, which I mentioned to you already, the electrolytes, and electrolytes are nothing more than these elements that are in solution, and they're in solution as in ionic form, either positive or negative cation. So anything that is a strong electrolyte and that is a good conductor of electricity are those ionic compounds that are soluble, those strong acids, those strong bases, things like potassium bromide, nitric acid, hydroxide, potassium hydroxide, sodium chloride, okay? The non-electrolytes are covalent compounds other than the acids, covalent compounds that will not, they don't dissociate in solution. I've seen lots of times, I've seen people take water and break it down. That's not the case. Water is covalent. It's not breaking down into their respective ions, okay? So you keep them intact. If you want to show them in the solution, you keep them intact, spread around through the beaker. And furthermore, not having a charge on them, they are considered non-electrolytes and therefore do not conduct electricity. The weak electrolytes are those that are weak acids, defined as a weak acid or a weak base, or any of the ionic compounds that are classified as insoluble, okay? And so they would still conduct electricity, but not as intense as a strong electrolyte, okay? This kind of summarizes all of the conditions to define what's a strong electrolyte, weak electrolyte, and so forth. This is a kind of a diagram of a beaker with a couple of electrodes in there, and you got that lightning rod there to demonstrate that that current is running through simply because there are ions in solution, okay? It's ions that carry the charge. If you have no ions, there's not going to be any charge being carried over from point A to point B, and you have this scenario where you have no electricity, basically acting like a light switch. The non-electrolyte would be the light switch on the off position. The electrolytes would be the light switch on the on position, okay? Electrolytes are crucial, very important. They're important in our body. It's how we get electrical signals from point A to point B. Without them, our head couldn't talk to our toes. All right, so to depict diagrams or beaker diagrams, like I said, you can either be given the formula and you write the diagram, or you're given the diagram and determine is it strong, weak, or non. Well, we can see here that magnesium hydroxide, based on its solubility rules, it is insoluble. So the bulk of magnesium hydroxide is down here at the bottom. And then we got one set of ions in solution. So that definitely is weak. Okay, it's a weak electrolyte. Here we have CH4, which is nothing more than a covalent compound. We may not know what it is, but all we see is carbon and hydrogen, which hopefully we're learning that whenever you see carbon and hydrogen, we call that a hydrocarbon, okay? It says no ions in solution, they remain intact, and this would be a non-electrolyte. And then potassium chloride, because potassium just happens to be part of the big four, makes it very soluble. And then we got all the ions in solution, paired up, don't put them separately. I've seen cases where they may add, 4 positive ions and then 2 negatives. Well, there's a problem with that. You got to have equal charges. Okay. So that would be a strong electrolyte. All right, so I got a few more here, and we're going to call it a day here pretty soon. All right, so here we're going to classify this as a strong electrolyte, a weak electrolyte, or a non-electrolyte, okay? Now, if we look at the formula, the first thing we're going to do is find out what it is. The name of it is barium sulfide, okay? That's where nomenclature is important, because now we know what to look for with respect to either the anion or the cation. And if we go through the solubility rules, you'll find that sulfides are normally insoluble, except when it's attached to barium, okay? Sulfides on the right side of that column. All right, so being attached to barium makes it soluble, therefore it is a strong electrolyte. All right, silver chloride. A good thing here is you see a good thing to as a flag is a silver, okay? Being flagged as silver should indicate as a heavy metal, which normally would suggest insoluble. So we go and verify it. We find that the chlorides normally are soluble, except when they're attached to the big metals, and silver is one of them. So therefore, this is classified as weak because of it being insoluble. Potassium, you don't have to go any further. Potassium is part of the big four. All right, so automatically soluble, automatically strong. Okay. H2CO3, recognize that you got hydrogen written first. That should suggest an acid for you. So you go through your list of acids and determine which one it is, and you'll find out that this is a weak acid, okay? Weak acid, and it's one of the weak acids that we gave you. So that means that it is a weak electrolyte. Carbon dioxide, totally all covalent, okay? Nothing ionic about it. Being covalent, it is a non-electrolyte. Number 6, like number 3, you got sodium first. So all you got to do, like I say, like number 3, which has potassium, this one is sodium, part of the big four, automatically soluble, automatically strong electrolyte. Calcium carbonate. Carbonates are classified as insoluble, and unless they're bonded to the big four, of which calcium is not. And so it is a weak electrolyte because it is insoluble. Then we have number 8, which consists of nothing but carbon, hydrogen, and oxygen. I didn't mention what it was, but I hope that you recognize all you see there in the form. It's carbon, hydrogen, and oxygen, which would tell you, okay, I have a covalent compound. Having a covalent compound means that it is a non-electrical. Number 9, like number 6, has sodium up front, so automatically soluble, strong electrolyte, and then lead, which again is a flag, like in the case of silver, number 2, a flag that possibly it is insoluble, but and that's the case. That case is true here because it is insoluble. You know, unless the lead is bonded to acetate or nitrate. Okay. Basically, those are the only examples where you got lead soluble. All right, that, ladies, is the end of chapter 9, which all done. Okay, well, we can, we got 30 minutes left. I have no problems to stop it here. We can stop it here, and we're getting there. Yeah, we're getting there. You're basically like what, 9 more, 6, 7 more chapters, and we're a little bit over half now. All right, so don't forget, next week we'll go ahead and just cut it short here, give you some time to digest all this. And next week you have the exam. I'm going to end up having 2 videos, so it'll be a part 1 and a part 2. Let's see how that goes. So I think if sometimes what happens when I get a glitch like that, that video gets canceled out. I don't know why, but if it does, no worries. You can go to my other classes and search. They're up front. Search for these this chapter, and I talk the same stuff there. All right. Well, and remember, you know, I actually, if I don't know if you're what your major is, are you going to go on some place in the medical field other than nursing? Because I know nursing, this is all the chemistry you need. But moving on up, you might sticking with nursing, okay. And I'm not sure about nurse practitioner if they require any more chemistry, but I need to find out. Anyway, yeah. All right. Well, you ladies have a good weekend and safe weekend. We'll see you next Friday. Don't forget the exam. And if you have any questions, shoot me an email. Feel free to come to either one of my Tuesday and Thursday classes beforehand. I got a refresher. I got one at 1 o'clock for between 1 and 2:15, same link. They're going to be, we just got finished up with chapter 9 with them. And so we'll probably, if they don't have any questions, I will continue with chapter 10. And then I got a class at 4:15 through 5:30. The GCC also group, but the evening class. And they also are done with chapter 9 like you guys. Yeah, you're welcome to come to those. And if you have questions, come to those and start the class off with questions. I'm sure they would appreciate it too. If not, I'm going to just continue to lecture. All right. All right. Well, thank you. Thank you, ladies, for showing up. I appreciate it. I've had one class before where I lectured and I was here by myself. I went ahead and lectured anyway because I knew some students needed to view the video after the fact. So, all right. I thought Debbie was going to have the the sole audience there, but you showed up, Ashley.
Maybe next week.
Okay.
You know what I think it is, Dr. Fred? I think it's when we're this deep into it,
Yeah.
At least for me, I enjoy listening to it the first time, but I really absorb so much more when I can stop the video
Yes.
and think
Oh,
it
yeah.
through, and then I can move on. So maybe a lot of the people that aren't joining us on Friday afternoon, maybe they are doing that. You know, they're just
Well,
going slowly.
I would think so, but when I look at the number of views of the video, it starts off in the beginning, literally everybody's viewing it, and then it like starts to do what it's doing now. I think the last video, I think I had 2 views, and there's
Okay.
so I don't know. That I
Well,
haven't figured it. Yeah, I haven't
end up,
figured it out.
you know how you post Dr. Kim?
Yeah.
I end up watching her videos. I watch you live and then I watch her videos.
Well, that's
Because I
good.
figure there
Yeah.
might be something that she says that you don't say, or something, I might have learned something from you that she didn't cover. So
Right. Yeah.
that's what I've been doing.
And I emphasized that in the beginning. I said, you got a lot of people, not only us, Dr. Kim and myself, but if you Google YouTube for this topic, you're going to have tons of videos of other instructors. So,
Yeah.
and sometimes listening to the same topic a different way, a different voice, it clicks something. And
Right.
yeah, I don't have a problem with, whatever it takes for you guys to grasp the concept, listen to whomever.
Yeah. That seems to be working for me. So I'm grateful that you posted those videos, because it really does help a lot.
All righty then. Well,
so, all right. Well, have a good weekend.
All right. You too. All right. Take care.
All right.
Bye-bye.
Take care. Bye-bye.